Hey guys, welcome back to DSIM Engineering channel. I'm glad you guys are back. So today, the way I want the channel to kind of flow is one video talks about a general topic about DSIM engineering, and then the next video would be talking about real life problem that I deal with to give you guys just a better idea of what DSIM is. So today we're going to talk about an issue that I had to troubleshoot, where a vendor did a PM on 5 UPS devices, and then after they were done with the PM, I lost communication with them on my SCADA platform. So we're going to go through a PowerPoint and then like some drawings about like what I did to actually figure this out. So let's go. All right, so anytime you're going to troubleshoot a problem, after you make your problem statement, knowing what you're looking for, then you need to figure out, okay, you need to develop some kind of functional diagram or get a block diagram showing, okay, how does the communication work? In this case, I'm trying to solve a communication problem. So there's a couple things I need to know. I need to know how my SCADA platform, because that's where I'm seeing the alarm, right? I need to figure out how is my SCADA platform talking to these UPSs in the field. Okay, so a couple things we need to know. So Modbus is the protocol being used in this scenario. So Modbus is an industrial protocol. It's been around, I think, since either the 80s or the 90s. It's been around for a while. It's a very common protocol. Anytime you're looking at EPMS, BMS devices these days, depending on the vendor, most of the time it's going to be Modbus. They may use SNMP. They also may use BACnet. There's different options, but in this case, we're going to focus on Modbus. So in general, how Modbus works, in this scenario, this is a Modbus RTU network. So the way this works is we have this Modbus gateway, which is, as you see, there's two polarities, a positive and negative, and a shield. So this is shielded cable. It's shielded twisted pair cable to minimize the noise that's inherently going to be in these environments. So as we can see on the red, these are daisy chained together. So all the positive wires are daisy chained from one unit to the next. And the same thing applies for the negative polarity. When you do a daisy chain network, it has to be daisy chained this way. Typical errors you're going to see if you're getting no communication is you may have these swapped on one of the devices, right? So if you have the black and red mixed up here, that UPS won't communicate. If you have a break in one of these wires, that can definitely shut off all communication. If you have a bad cable on one of these, it's going to shut off communication to half the network. So that's a pretty big deal with RS-45 cabling. Also, our SCADA platform is talking to this Modbus gateway over the network. So it's a layer 3 IP addresses. So the first thing you're going to want to verify is, okay, can I reach this gateway, right? Is it powered on? There's two ways you can't reach a gateway. It's either turned off or it somehow forgot its IP. Maybe it got power cycle and just went back to factory defaults. I've seen that happen before. But so the SCADA platform will request information. So it wants to know, for example, okay, I'm wanting these particular data points that I know are stored on these registers on this UPS device. Let's say it's looking for kilowatt hours, for example. It will say, Modbus gateway, please get me. I'm requesting to know what the KW value is on UPS 3. The Modbus gateway will process that over Ethernet and say, okay. And then it's going to send a Modbus RTU message to the entire network. So this is why it's so important to get your addresses correctly. So in this case, this is slave address 1, slave address 2, slave address 3, slave address 4, and slave address 5. So the Modbus master sends requests and the Modbus slaves send responses. The slaves can only reply when they're being spoken to. Yes, I know that sounds terrible, but that's just the way this is. So in this scenario, the Modbus gateway will go, okay, it'll say, it'll create a package in a Modbus RTU package, and it will say, okay, in that package you're going to have The amount of registers it wants from UPS 3, it's going to tell you, okay, I need you to start from this register number and give me all the data in this, from that register to this register. But one of the most important parts are the function code and the slave address. So if it's reading input registers or holding registers, we can get to that in another video, but the function code matters, and then the slave address matters. So it's going to send this message that's going to go to the UPS 1, 2, 3, 4, and 5. But because in the Modbus message sent from the master, the request message, it's saying slave address 3, even though this message is broadcast across the entire RS-485 network, only UPS 3 is going to respond because that is the address in the master Modbus master request message. So UPS 3 would ideally respond back in a certain time period that you set up. If you set it up for 1 second and the UPS doesn't respond in 1 second, you'll get a Modbus exception code 11 error, or you might see it as an hexadecimal 0B. So this is in general how this is in my specific real life scenario. I need to verify, do I have communication from SCADA to gateway, and do I have communication from gateway to each individual field device? Hope all that makes sense. So also the polarities matter. So this down here is what the waves would look like. So let's do this. On the positive wires, you're going to see, for example, this is what the waveform look like on an oscilloscope. And on the black, it's going to be the opposite because it's a differential signal. So they're opposite of each other. So that's just how it looks on the wire. So if you come up with a situation where the wiring, the square wave doesn't look like a square wave, then you have bigger issues. But that is that. Alright, so now we're going to run through just a systematic troubleshooting methodology. So we're going to start with a problem statement. So on the SCADA platform, there are communication failure alarms on all identical UPS units after the vendor performed preventive maintenance. Of course, this won't be the first time I'm sure anyone's been through this. It was communicating before the PM started. After they finished, it wasn't communicating. So something went wrong. So then we got to think about, okay, how can I isolate the problem? So we already went through, obviously, the last video talking about how everything works, how everything is connected. So let's figure out, okay, I need to make sure, do I have communication to the Modbus gateway of the network? Is the Modbus gateway configured correctly? And am I getting data from the UPS back to the gateway, gateway to the UPS? These are 3 things I need to verify. So when I was solving this problem, I used my favorite command prompt command, networking command, ping. So I located the IP address of the Modbus gateway, and I just did a ping command, and I got 4 good responses back. So I'm like, okay, it's on the network. I know what's turned on. I also walked over to the gateway itself, and it was powered on. So I'm like, okay, well, we're good there. The easy part's done. Okay, now this next part, verify the Modbus gateway is configured correctly. So there's a couple different Modbus serial settings that are common to every single Modbus RTU setup. The baud rate. So the baud rate is how fast the bits are being transferred on that Modbus network. So you'll see baud rates of 9600, that's pretty common, 192, 38400, I've seen those, I've even seen 57600. So the gateway has to have the correct baud rate. It basically sets the baud rate for the network. So if this baud rate doesn't match the baud rate on the UPS slave device cards, nothing's going to communicate. So you got to verify that. You also have to verify the parity setting. So parity basically is an error checking mechanism to make sure that like whatever message are being sent from one device to another, that the data is what was sent is staying the same. It's not changing. So you can have no parity, or you can have even parity or odd parity. All right, so continuing on, so number of data bits, this has to match on the gateway, and on a slave device, it's basically just saying like how the data is packaged. You usually see it as 8. I haven't seen it set up any other way, but yeah. And then, of course, for some gateways, you're going to have 2-wire and a 4-wire setting on the communication gateway. All this means is, like we saw in the earlier drawing, you had a 1 positive wire, 1 negative wire, so that's a 2-wire RS485 network. There is another way to do it. You can wire it up 4-wire. I rarely see it this way, but if the network's wired 4-way and you set the gateway to communicate over 2-wire, it's not going to work. You will get no communication. So you got to verify that. And of course, verify your timeout settings are correct. Like we talked about in the video, if you have timeouts for how long the UPS can respond back to the gateway. If you have it set so low where the UPS never has time, you just get errors, Modbus errors, exception codes all the time. So I verified that, so we were good there. So then we get to our final step, which is, can I verify there's data going from the Modbus gateway to the slaves themselves? So there's a tool called ModScan. If you ever use Modbus, you can look it up online. ModScan is a great tool. Basically how you use it is you plug in this case, we plug in the gateway, Modbus gateway IP, and we select service port 502 because that's the default Modbus protocol port that it uses to communicate. And then we pick a slave address. So in this case, let's say we wanted to talk to slave 1. Since that's the first one in the chain, it's always good to verify that. If you have a problem talking to the first device in the chain, then you're probably going to have issues going down the rest of the chain. So we can go over that in a different video. But the goal is you can look at data on the UPS by using ModScan to make sure there's data there. But when I use ModScan, I kept getting an error saying that my connection kept being terminated. So that's definitely a red flag. So that's a red flag for sure. So I was good on the first 2 things, and then I'm finding out, okay, so I don't have data between the Modbus gateway and the UPS. So that can mean 2 different things. There's something wrong with cabling somewhere, or the slaves themselves are just not responding correctly because maybe their communication cards are broken or something. So after all of that, after verifying that I couldn't get data from the gateway to the UPSs, and I was getting that weird TCP IP terminated error when I tried to mod scan it, we actually found out 2 things were wrong. The Modbus gateway itself was a problem, right? Okay, kept giving me that error, even though port 502 was open on the Modbus port, but it still was giving errors. So also verify with an oscilloscope that I was getting data outside of the gateway. So the 485 cable at the bottom. Actually, I can probably show you what I'm talking about. So the 485 that's wired into the bottom here. Sorry. For ports, in this case, it's 1, 2, 3, or 3, 4, 5. But the wires for those, I saw physical signals coming out of it, that it was sending the messages. But when I went to the UPS side, on the other side of that same cable, I was getting no signal, like nothing. So we actually found out there was an open across the communication, that cable, going from the gateway to the first UPS. And like we know from our drawing earlier in this video, if you have an open in that first cable, you're not going to be able to talk to anything in the rest of the 485 Modbus chain. So it was 2 separate issues. This thing was busted, and the cable itself just failed. And it all happened after the PM, so God knows what happened when they did that PM. But so I have 2 options. I had a replacement gateway, so that wasn't a problem. But I either need to get with a vendor to rerun all the 485, or for these units, they actually support a communication card that supports Ethernet Modbus TCP, which is communication over Ethernet cable. So realistically, I think what I'm going to do is actually just, because apparently this has been a problem for years, these things dropping in and out of comms. think I'm just gonna get a vendor to pull a new Ethernet cable to them, get a new network switch, and just get rid of this cable problem altogether, and just do Modbus TCP over Ethernet. So, but yeah, guys, thanks for joining with me today, and that was a real life problem I had to deal with.